Example 7 or example 12 says repeated application of the chain rule. So we're actually going to have a chain rule inside of a chain rule. It can happen more than once, and that's perfectly fine. So it says find the derivative of f of t equals sine cubed of 4t. Again, a nice test question here, so I want you to pay attention because a lot of people forget to multiply times the derivative of the inside of the inside. You're going to see what I'm talking about in just a second. So if we find the derivative of this, let me go ahead and actually rewrite this. How about I write it as the sine of 4t quantity cubed so you can really see what I'm doing. So if I want to find the derivative of that, I'm going to drop the power. I'm going to use the general power rule. Drop the power, inside stays the same, power minus 1, derivative of the inside, right? So that would be 3 times sine of 4t quantity squared, but then I need to multiply that times the derivative of sine of 4t. Well, the derivative of sine of 4t requires a chain rule in itself, right? The derivative of sine of 4t would be, well, the derivative of sine of u is cosine u prime. So this would be cosine of 4t times 4t prime. So what's the derivative of 4t? That's a 4. So a lot of people would forget to multiply times that 4, that green 4 that I've written there. So let's put it all together. Now I have a 3 times a 4, so what am I getting? 3 times 4, I'm getting a 12. And then I have a sine of 4t squared, or a sine squared of 4t, I don't care how you write it, times a cosine of 4t. And there it is. So again, why would most people miss that problem? Because they would forget that 4 there. So it's a 12 sine of 4t quantity squared times cosine of 4t. All right, the derivative of the natural logarithm function. So here's where we need to learn the derivative of natural log. It's the last of our transcendental functions that we'll be doing, except for inverse trig, but we'll do that later. Don't worry about that. So derivative of log functions. And what this tells us is what the derivative is. First thing you need to remember is that the domain of log functions are restricted. We have to talk about positive values only. So we are going to assume for the rest of all of this that our values are positive, because remember, the derivative only exists if the function is continuous. So the function must exist. The derivative only exists if the function exists. Okay, so what is the derivative of the natural log of x? And this is the big one. The derivative of the natural log of x is 1 over x. So likewise, we could use the chain rule to extend it to say the derivative of the natural log of u would be 1 over u, but then you need to multiply that times u prime, right? So they just write it as u prime over u, but I like writing it as 1 over u times u prime. So this is another rule that you have to memorize, just like you did with all the other rules, product rule, quotient rule, for all the other transcendental functions. This is a rule that you definitely want to memorize. And again, while this is an online class, and if it's online, I allow a note card in your next class if you're taking Calc 2 that is not offered online most likely, and you are not allowed note cards during the exams. So they do expect you to commit all of these functions to memory. Okay, so let's look at this first one. It says find the derivative with respect to x of the natural log of 2 of x. Well, what would you do here? Well, to find the derivative, you do, remember, the derivative of the natural log of u is 1 over u. So this would, the derivative would equal 1 over what you see on the inside, which is 2x, times the derivative of the inside. So that's 2x prime. And the derivative of 2x prime is simply 2. So putting that together, I'd have what? 2 over 2x, which could simplify to be 1 over x. So there's my answer for that problem, 1 over x. Let's do a little more complicated example. How about the derivative with respect to x of the natural log of x squared plus 1? Again, the derivative of the natural log of u is 1 over u times u prime. So this is going to be 1 over x squared plus 1. Keep the inside just the same. 1 over the inside times the derivative of the inside. X squared plus 1 prime. Well, the derivative of x squared plus 1 is 2x. So here I'm ending up with 2x all over x squared plus 1. Notice nothing factors and simplifies, so that would be our final answer. 2x over x squared plus 1.